In this video, I'd like to go ahead and talk about the growth archetype, one of the two most basic archetypes, the other one being the goal-seeking archetype. The growth archetype, the causal representation of it, we begin with an action which produces a result. And that result influences the action to produce more of the same result, so that it's actually looping in a reinforcing manner in the same direction. And what we end up with is a growth situation. Think of what happens with a savings account where the principal periodically produces interest and the interest adds to the savings account, making more money in the savings account, which then again adds to the interest, which adds to the savings account. And a reinforcing growth structure produces exponential growth. The growth is the emergent characteristic of the structure, because either one of the entities alone, if you think about the principal or the interest, either one of them independently doesn't produce a characteristic of growth. So exponential growth is the emergent characteristic of this structure. You'll find that all of the archetypes have emergent characteristics, which is an aspect of the archetypes that you talk about overall, because it is in fact that emergent characteristic which gives you the pattern of behavior that helps you identify what the archetype is that's the source of that pattern of behavior. Now note that the reinforcing or growth archetype can actually be virtuous or vicious depending upon whether or not the structure is desired. Consider the run on a bank. The more people are concerned about the health of the bank, the more they withdraw their money, and the more they withdraw their money, the more concern there is about the health of the bank, and it ends up being a vicious, decreasing loop as opposed to an increasing. So it can run in either direction depending upon whether it's something that's desired or not desired. And the thing to remember about growth archetypes, or the growth structure itself, nothing grows forever, so that any time you run into a growth scenario, sooner or later it will run into a limit, and the growth will slow down or stop. And note that there could actually be numerous elements in this loop. This is the simplest loop, which is 2 elements in it. But there could be 6, 8, 10, 12 elements in this loop, and you tell that it's a growth loop by counting the influences in the loop. And if there are 0 or an even number of positive influences in the loop, no, that's right. If there are 0 or an even number of opposite influences in the loop, then it's a reinforcing loop. If there is an odd number of opposite influences in the loop, then it's a goal-seeking loop, which we'll talk about in the next video. Now, moving forward, we talk about this in a simulation version of the structure, where this is the result, this is the action, this result influences the action, and here we've simply added a factor that can be varied from 0 to 1 to provide a sense of the implication of the action. What happens when you vary the percentage of the action that contributes to the result. So here the action itself is defined as the factor times the result. Now if we go ahead and run this model, you'll note that it shows the characteristic exponential growth, and after 10 periods, the answer is 1024, which is the sum of all of the increments, because if this starts out at 1, the next time it's 2, the next time it's 4, the next time it's 8, and if you add them all up for 10 cycles, it ends up being 1024. If you change the factor so that the factor is 0.5, notice that the result after the same time period is only 57.6, which is an extremely marked difference between what it was for 1 and 0.5. And you'll notice that the two lines now vary where they didn't before. This is the action that adds the next cycle each time, and this is the result at the end of that cycle. So from here, it would probably be a good idea if you actually accessed this model and ran it a number of times. You can change the values of the factor and the initial value of the results, and you can run the simulation. You can look at the result values, or you can look at the tabular values after each period, and you can change the values again and run it. You can do this as many times as you like. The intent is to interact with the model to get a sense of what it feels like, what the implications are of changing the values back and forth. Hope you find this interesting and of value, and I'll see you in the next video. Bye.